camera images are the easiest type of data to collect. Cameras are cheap and plentiful and easy to use. Could we use images to localize our car? Precise localization through images is hard. In practice, camera images are often combined with data from other sensors to accurately localize the vehicle. But camera data combined with a map and GPS data can localize much better than camera images alone. Imagine a vehicle driving down the road that observes a tree on the right. The map shows several trees on the right-hand side of the road, all in different locations. How do we know which tree the vehicle sees right now? We can solve this problem using probability. Imagine that we are located at any one of the many points on the road. We use probability to determine which point is most likely to represent our actual location. We know we see a tree on the right. Some of our hypothetical points will see a tree on the right, and some won't. Surely we are most likely to be at a point where we would see a tree on the right. We can eliminate points on the map that don't see a tree on the right. We can continue to observe the world as we drive. Imagine we drive forward and observe yet another tree on the right. Looking at the remaining points on our map, we find only a few locations that have 2 trees in a row on the right-hand side of the vehicle. Surely we are most likely to be at one of these locations, so we can eliminate all the other locations. We continue this process using observations, probability, and the map to identify our most likely location. This process is called a particle filter because we are using particles, or points on the map, to estimate our most likely location. Of course, trees are relatively rare on many roads. However, lane lines are common on most roads. We can use the same principles of a particle filter to take camera images of lane lines and then use those images to localize our vehicle on the road. We can compare our camera image of the road to a map. Our camera image will match up very well with some portions of the map and less well with other portions of the map. This is an example of visual lane line matching. Blue represents lane lines from 2 different locations on the map. We want to determine which location is more likely to be our present position. Red represents the lane lines observed by the vehicle camera. The red lines match the blue lines on the right much better than they match the blue lines on the left. Thus, we are more likely to be at the map position that corresponds to the right-hand image. The advantage of visual localization is that image data is easy to obtain. The disadvantage is the lack of 3-dimensional information and the reliance on 3-dimensional maps.